Less than a century after Mendeleev published his periodic table, scientists had arrived at a seemingly beautiful simplification. All this is made of just three fundamental particles: the proton, the neutron, and the electron. Now, this was a giant step forward in our understanding of matter, but there were still phenomena that couldn't be explained in terms of just these three particles. In the early 20th century, scientists recorded mysterious new particles bombarding the Earth from outer space. They had discovered cosmic rays, and they rushed to study them. By the late 1930s, they came to the conclusion that the experimental results could not be explained using the then known fundamental particles: protons, neutrons, and electrons. Some other, more mysterious particles were responsible. Using cosmic rays to detect new particles isn't particularly efficient, however, because you never know when or where they're going to turn up. It'd make much more sense to make your own. Thus entered into physics this, the particle accelerator, a way of making cosmic rays in the laboratory. Particle accelerators built in the 1940s and 50s led to the discovery of many new particles, given exotic names like pions, sigmas, lambdas and deltas. By the mid-1960s, over 80 apparently fundamental particles had been discovered. So many, in fact, that particle physicists began to refer to them as a zoo. This was no better than Mendeleev's periodic table. Eventually, order and elegance were restored by American physicist Murray Gell-Mann.
There was a comparatively simple underlying structure to all this. And the classification, say, of the strongly interacting particles depended a great deal on symmetries and in particular broken symmetries, approximate symmetries that were violated.
Gell-Mann had noticed patterns which physicists can explain in terms of symmetries, and by identifying the underlying symmetries, he found he could explain the properties of the particles. According to him, protons, neutrons, and the whole zoo of apparently fundamental particles were made up of just three types of basic building blocks, which he named quarks.
Just the simple inspection of the particle chart would suggest immediately the quark scheme. So the difficult thing was not noticing the quark scheme. That was essentially trivial. What was difficult was believing that it had any relevance.